Hello, fourth graders. Welcome to lesson 3.4. Today we are going to talk more about equivalent fractions. All right, let's take a look at this story here, though. Imagine this. Jamie's mom made a small chocolate cake for dessert. She told her to cut it into four pieces so they could all have 1/4 of the cake. Instead, she cut it into 8 pieces. How many pieces, or what fraction of the cake, will each person get so that it is equivalent to what her mom told her to cut? So imagine that, right? Imagine that you're supposed to cut something into four pieces. Oh no, right? You made an extra cut, couple extra cuts, right? And now it is 8 pieces. So they wanted to have 1/4, but now they have pieces that are eights, right? They wanted to eat this, but instead they have this. So if here they wanted to eat 1/4, what do you think they would eat over here if they each wanted to have 1/4? What do you think? Well, look, let's see. Okay, so we want this amount of space, right? So if we color in this and this, that's going to be worth the same as what we had before. So how would we determine that? Well, 1, 2 out of 8 pieces. 1/4 and 2/8 are what we call equivalent fractions. Even though the numbers are different, right? The numerators are different and the denominators are different, they are worth the same amount. Now, let's go into this page in your math journal. Okay, so go ahead and take a moment and find page 77 for me. All right, we're going to work on this a little bit together and a little bit on your own. First thing we need to do here is to color 1/2 of each circle. Okay, so right, the key thing here is don't worry about the numbers yet. Just color the same exact amount that you see on the first pizza. Right, so we're coloring that and we're coloring that. Don't look at any of the numbers yet. Okay, so now we can look at the numbers, right? We colored the exact amount that was shown here. So what have we colored here? 1, 2, 3 out of 6. What have we colored here? 1, 2, 3, 4, 5, 6 out of 12. Okay, so these are examples of equivalent fractions. We'll talk about these in just a moment. Let's do this one. Okay, number 2, you're going to color 1/3 of each circle. So 1/3 here, and then color the exact same amount on the next one. See, right? Remember when we do fraction circles, equivalent fractions could lay right on top of each other. And color the exact same amount here. All right, now we're going to name the fractions. 1/3 would be here. What is this fraction in this spot? It would be 2/6 and 4/12. All right, go ahead and do number 3. Color 2/3 of each circle, right? So do all your coloring first, and then go back and name your fractions. All right, so let's see what we're doing here, what this means, okay? What all of this coloring relates to. So our goal here is today is to generate an equivalent fractions rule, okay? So we can use fraction circles and number lines, but we're going to also learn kind of a shortcut method, okay? And that's described in this standard, but I'm not going to get into that right now. But you can see that we do have the word equivalent there in our standard. So in our first problem, we had the numerator and the denominator. And let's look at these 1 to get to 3 and 2 to get to 6. So I'm going to think, well, what number could I multiply both of those in order to change this to that? Well, both of them I could multiply times 3, right? 1 times 3 is 3, 2 times 3 is 6. On the third one, right, how would I get from 1 to 6 and from 2 to 12? Well, 1 times 6 is 6, and 2 times 6 is 12, right? I multiplied the same thing. I could, and it works, right? If I multiplied the top and the bottom by the same number, I could get an equivalent fraction. These are equivalent fractions. How do we know? How do we know these are equivalent fractions? Because when we colored them in, they were worth the same amount. That is how we know. Okay. Now, our next one, right? 1/3, 2/6, and 4/12. That was the second one back here. These are equivalent fractions too. Okay, and how do we know that? Well, we could color in the same amount. We could also use that little kind of trick that we're talking about. All right, well, how to get from 1/3 to 2? So times 2, does it work? It sure does. What about getting 1/4, 1/3 to 4/12? Let's see, the top would be 1 times 4 equals 4, and 3 times 4 equals 12, right? So look at this. Every time we have equivalent fractions, we can multiply the bottom number and the top number by the same thing. So, right, here's an example, all typed out nice and pretty. So our rule here, our rule is if the numerator and the denominator of a fraction are multiplied by the same number, it can't be 0 though, the result is a fraction that is equivalent to the original, right? So you could take any fraction. You could take 1/2 and you could say, okay, as long as I multiply the top and bottom number by the same thing, then my result is equivalent. So 1 times 10 and 2 times 10. An equivalent fraction, whoops, 1 times 10 is not 20. 10/20. These are equivalent. Okay, so we could multiply the top and bottom number by the same thing. Let's do 2/5 here together. How about if we do 2/5, and then we'll multiply the top and the bottom number times 2. So what do you think? 2 times 2 and then 5 times 2. What is the fraction if you do that? You should have said 4/10. 2 times 2 is 4. 5 times 2 is 10. 4/10. Now we can also use this to find missing numbers. Let's say that we have something here, and we don't know one of the numerators or the denominators. So, but we do know one of them. So look here, right? I can think 10 times something equals 100. Well, 10 times 10 equals 100. So if 10 times 10 equals 100, then I have to do times 10 on the top also. My answer would be 60. Here's another times 10. 7 times 10 equals 70. So 10 times 10 times 10, not 100, times 10. I'm sorry, already thinking 100 because 10 times 10 equals 100, and that would go there, right? It would work with the numbers that aren't 10 as well. Sometimes we use that rule to fill in missing numbers. Okay, we could even go backwards. Right now, division and multiplication, we know that those are inverses. Okay, and so if we divide, and we won't do this a whole lot, but I want to show it to you. If you divide but the same thing on the top and the bottom, it works too, right? 30 divided by 10 equals 3, and 100 divided by 10 equals 10. So these are equivalent fractions. If you don't like looking at it like that, well, just flip it around and make it look like this. Okay, then you can put multiplication in there, but you can divide the numerator and the denominator by the same number and get a different equivalent fraction. All right, so our goal today is going to generate equivalent fractions using a rule. and you now know that rule. Let's take a look a little bit together here at Math Journal, page number 78. Take that out. I guess you didn't have far to go because you were already on page 77, so you just had to go to the next page. Now, our goal here is to fill in these name collection boxes. So we're thinking, well, what fractions would be equivalent to this guy, right? So we write the missing number in each fraction so that the fraction belongs in the box. Fill in the empty boxes with the fractions that belong. Okay, so I'm going to do 2/3 over here. I'm going to do number 3 so that you can make sure you know this. All right, we're going to figure out 2/3 is equal to all these. So I'm going to have you write 2/3 on all of these boxes. 2/3, 2/3, because we're finding equivalent fractions for 2/3 because that's the one that's at the top. 2/3, 2/3 equals. All right, so let's look at the first one. 2/3 equals how many sixths? All right, well, look at what we know. So 3 to 6. 3 times what equals 6? 3 times 2. And if you do that on the bottom, you have to do that on the top. That's the rule, right? You have to do the same thing on the top and the bottom. 2 times 2 is 4. Okay? Let's look at this one. 2/3 equals 8 of something. All right, so we know the top numbers, the numerators. 2 times what equals 8? 2 times 4 equals 8. And so what do we have to do on the bottom? 3 times 4. 3 times 4 equals 12. Now down here, there's nothing here, so we can pick. I'm going to do times 5 because it's easy. Top and bottom, same thing. So 2 times 5 equals 10. 3 times 5 equals 15. Okay, and then you have 2 more to do there. You're going to do number 1, number 2. You're going to finish number 3. And down at the bottom, you get to make up 2 of your own. If you do have somebody who can try to, at home, who can solve your problems, great. If not, then you solve them. Okay. So you need to make sure that these are filled in by either your friend at home or by you. All right. That is the equivalent fractions rule, fourth graders. I will see you next time, and good luck.